Hi, I'm Edward Chang. I'm a neuromuscular massage therapist in the state of California, and today I'm going to be discussing about cupping. Now, hopefully you have gone over the fascia video. If not, I'm going to try to link it. Still trying to get a hang of the YouTube thing with the linking thing, and I'm trying my best, trying to get it to the point that I want it to. Just believe. I'm trying to get a hang of it. I'll get there eventually. So basically, you probably learned about fascia, but you haven't learned about cupping. And cupping is one of those things that they use in traditional Chinese medicine. It's a little tiny cup. They just basically go ahead and put it on the skin, and it creates some suction. It's been used quite a lot. It's basically used to kind of move chi or kind of suck up the stagnant chi, and to kind of move things along. Now, a traditional Chinese doctor will let you in a lot more details than that, but you just kind of get the general gist of it. But that's basically what it is, and it's a very useful tool. And it's been used a lot in traditional Chinese medicine, and it's used by some massage therapists as well. The old method was considered sometimes very dangerous, and even a qualified practitioner could sometimes cause more harm than good, just because the old method of using cupping um, could create too much suction on the skin, and it would basically um, do more damage than harm, just because it was so much suction, and it would detach the skin from the muscle way too much, and then start affecting the muscle itself. Um, and that was that's just not good. So instead of an indirect effect on the muscle, it had an extreme effect on the muscle. Not good. So basically, what cupping is, like I explained before, is a little cup you put on the skin. Traditional way was with a little cup, a little glass cup, and they would light a little cotton ball with alcohol, and they'd basically suck the air out of the cup by lighting the fire underneath the cup, and so all the air would be consumed. They would go ahead and place that cup on the back of someone with a little bit of lubricant, and that was cupping. Technically, you're not supposed to put lubricant, but we can get into the arguments of that later on. Um, it's just if you don't use lubricant, there's not too much suction, or it's very, very minimal suction, which then doesn't have the hickeys basically appear. Because they do appear. There's these black marks that will appear after cupping. And it looks like a hickey almost. Sometimes it goes a little too far, and it's like really, really dark. In that case, bad practitioner. But yeah, and also burns. Burns was something that was big. But nowadays we don't do that. We actually use a little plastic thing, and we put it on the skin, and it sucks up the air on its own because of the quality of the plastic. It's like a suction cup, and we've used those. And we also now use these plastic ones that you have a actual suction vacuum thing kind of attached to it, which goes ahead and sucks out the air out of the cup itself. And those are much more safe, and they don't tend to leave hickeys. But I wanted to go ahead and discuss, apart from all that, the real reason why it's important to understand cupping as a massage therapist and as an athlete, because some of you do use it. It is readily available to the public now. Not that you should use it, but you know, uh, regardless, I want you to understand basically the fundamental physics behind it, so you understand what it really does. Now, when you go ahead and put on the cup, it's basically here you got your skin, here you got your blood supply, here you got your muscle, and here you got your fascia, right? We talked about fascia, right? So basically, when you go ahead and put it in on this cup goes on. And this cup is going to create a little bit of a vacuum. So it's going to suck the skin up. It's going to have a low pressure environment, and it's going to suck the skin up. The skin is going to move. And what basically happens is this skin moves up, right? Because it's low pressure environment. So it moves up. And what happens is this fascial tissue basically gets released. It gets released and basically creates now that movement that was restricted by the fascia before. So basically that's what it does. It sucks it up, it sucks up the skin, and it releases that fascia. Now that's the fundamental property behind the cupping. However, there's more to it that a lot of people don't know about. And that is, this is a low pressure environment. If a muscle is contracted, if it is constantly contracted, it's going to create a what environment on the inside? If the muscle is contracted, it's going to do what? It's going to get bigger. It's going to restrict blood supply. This is going to get squished. Your blood supply is going to get squished. What's going to happen to the blood supply? It's going to get high pressure. So now there's going to be a high pressure environment on the inside. Now what happens in old traditional cupping is the capillaries that are embedded in the skin and some in the muscles break. And that blood seeps up to the surface because there's low pressure environment here, so that whatever blood's going to seep out is going to automatically go to the low pressure environment and it's going to reveal itself. On the surface of the skin, you'll see those marks being darker. Being dark, right? You'll see those hickey marks. So what happens when that muscle is more contracted? If this is a higher pressure environment, what does high pressure environment want to do? It wants to go to low pressure environment. You learned that in elementary school science classes. At least I hope you did. Right? The high pressure environments always want to go to what? Low pressure environment. There's more motion here. It wants to go to the low pressure environment to balance it out. Right? Always wants to do that. So guess what? If the muscle is more contracted, and this is a higher pressure environment, when the muscle is more contracted, what does it mean happens to the mark? The mark gets darker. That's cupping for you. That's cupping for you. The mark gets darker. So what does that mean for the people that use cupping? It means we can guess or we can evaluate basically an approximation of if a muscle is tighter or not just by the mark that's left by the cups. Because if it's darker, we know that that muscle is more contracted. Ta-da! Oh my god. So there you go. Cupping has a use. Scientifically has a use. A lot of people are not aware of it, but that's its use. That's its practicality from a Western point of view, not from an Eastern. Eastern, different story. Well, not really, but Eastern, different story. Trust me. You're gonna get confused if I tell you the Eastern version. You're like, what? Okay? There you go. There's a scientific explanation for it. A lot of people in the massage profession will maybe discount it or say it's useless, but there's actually a huge application for it, and it's based off of science. If you go ahead and use a simple formula, PV equals nRT, I wrote A. I don't know why. That should be an R. R, and my V is smudged into this P, which is bad. There we go. Okay. PV equals nRT, your basic pressure equation. Pressure and volume equation that you should have learned in your chemistry courses, which you were not ready for, because you needed physics before you could do this. But whatever. You needed to use it, Anyway, okay? If you're interested, plug this formula in to that concept. It's gonna work. And you're gonna find out. Ooh, it works. Believe me, you can derive it. You can derive it and prove through physics this is what's gonna happen. Ta-da! PV equals nRT. Just use that formula. Temperature difference up there. The temperature difference down there, which is probably going to be a little bit higher on the inside, right? Temperature is going to be higher on the inside because the muscle has more heat. Moles are going to probably remain the same. We're not dealing with the moles. We don't care about that, so cross out the N, right? T is already filled in. What's your R? R is a constant. We don't care about constant. Just cross that out of the formula, right? We don't care. You got pressure and volume and temperature. Temperature is going to increase. What's going to happen to the volume? on the inside where the muscles expanding, right? The volume of blood is going to go what? Down. What's going to happen to the pressure? It's going to go up. Put it together, people. So there you go. Hopefully you learned a little bit about cupping. If you want to derive it, I just gave you one of the formulas that you could use. There's plenty of other formulas that you could have used for this derivation. But there you go. So, I hope you learned something, and I hope to see you next time.